A linear relationship is essentially going to be looking for a change in your y values. They're referencing it as f of x. It means the same thing. Notice how we're increasing by 2 every single time. Well, we are increasing by 2 because each of these are increasing by 1. If I had jumped to 5, then this one would be going to 9. You see what I mean? Okay, all of these are growing at a pretty much an exponential rate. This is all doubling. This one goes from 1 to 1, 2 to 3 to 27. This is actually y equals, I think this is x to the third. Yeah, x to the third power. Choice 3. All going up by 2. Which domain would be most appropriate set to use for a function that predicts the number of household items? If you're counting the number of household items, you're using numbers like 1, 2, 3, 4. These are basically your counting numbers. Integers include negative numbers. You can't count with negative numbers. You can't count with fractions, and you can't count with numbers such as pi or square root of 99. And number 7, solving this inequality. I'm going to add 8 from the right side to the left side. I should get 15 minus 2/3 x is less than x. If I add 2/3 x, add 2/3 x, essentially what you get is 1 plus 2/3. 1 plus 2/3 is the same as 3/3 plus 2/3. I get 5/3. So I get 5/3 x. If I multiply this side by 3 and this side by 3, I get 45 is less than 5x. Divide both sides by 5. I get x is greater than 9. Choice number 1. In number 8, they're looking for the value of a car. The value of a car is given by this function v of x equals 25,000 times 0.86 to the x. How much more is a car worth after 2 years? So what I'm going to do is I'm going to plug in 2 and I'm going to plug in 3 and I'm going to get the difference in values. Using my calculator, I get these values, and then when I subtract them and then rounding to the nearest whole dollar, choice number 1. In number 9, the y-intercept is 3. Is negative 3. Choice 4, if I subtract 3 to get this equation into standard form, notice how in this case my y-intercept is negative 3. All these have to be put into standard form in order to determine the y-intercept. Number 10, here's another polynomial multiplication disguised in an area problem. They tell you a piece of paper has side lengths of 2x minus 6 and 3x minus 5. My paper is obviously not drawn to scale, so pardon me. Area is length times width, so I am simply going to multiply 2x minus 6 times 3x minus 5. 2x times 3x is 6x squared. 2x times 5 minus 10x, I get minus 18x plus 30. 6x squared minus 28x plus 30. Choice number 2. And number 11, I would use scrap paper. I would plot both of these points, 311 and negative 21. I connected them with a ruler. I then plotted all 4 of my choices. Looking at my choices, it looks like 2, 9 would be the best bet to be a member of that line.